Hi, and welcome to the third of 3 videos for section 1.5 for Math 126. This section has been about what? Solving equations. And up to this point, they've all been quadratic equations. We're going to look at 2 other types of equations we're going to encounter, which are rational expression, so RE equations, and radical equations. So equations that have roots in them. When we have these types of equations, so up until this point, I know when I gave you guys the first example, we checked our numbers to make sure it worked. In the perfect world, if you're on an exam, you'll go back and check all of your answers that you get. Sometimes, because of time constraints, you don't have that time. However, on these 2 types of equations, you must check your answers. And so we're going to do an example of each of these, and I'll show you why we have to check our answers. So the first example we have, we want to solve the equation 3 over x plus 5 over x plus 2 is equal to 2. So if I have an equation like this, an equation with fractions in it, what's the easiest way for me to solve something like this? So let's say I had, x over 2 plus 1 over 3 is equal to 7 over, 4. If I had an equation like this and I was trying to solve for x, what would I do? I would multiply everything by the LCD, right? Which is 4 times 3, it's 12, and 2 also goes into 12. So I multiply everything by 12 and I get what? 6x plus 4 equals, so that cancels, so 4 cancels with 12, 3, so 21. So then I move the 4 over, divide everything by 6, but in this first step, by multiplying by the LCD, I get rid of the fraction pieces. The same thing holds true for a rational expression equation. If I find the LCD, I can multiply every piece by the LCD, and I'll get rid of the fractions, and then it's just an equation I have to solve after that, not a rational equation. So my LCD is what? Well, it's x times x plus 2. Each of these denominators, this is a 1. So it would be x times x plus 2. So what I'm going to do is multiply x times x plus 2 times 3 over x plus x times x plus 2 times 5 over x plus 2 equals x times x plus 2 times 2. So now when I do this with the first term, what happens? The x's cancel out, so I get 3 times x plus 2. And then here, the x plus 2's canceled, so I get what? 5 times x. And then over here, if I multiply this out, well, x times x plus 2 is what? I'm going to distribute this x, so I get x squared plus 2x. And then I still have this 2 in front, so I get what on the right? I get 2x squared plus 4x. So now the fraction parts are gone. So we don't have to deal with fractions anymore. Now it's just an equation I need to solve. If I expand this, distribute the 3, what do I get? 3x plus 6. And then here, plus 5x. And so I'm going to move everything over. Well, let me do that in the next step. So equals 2x squared plus 4x. So now if I move these over, so minus 2x squared minus 4x, whoops. So minus 2x squared minus 4x. What do I get? I get minus 2x squared here. So let me do this. I don't want to have to deal with the minus sign. So let's simplify this one here. 3x plus 5x is 8x plus 6 on the left, and then 2x squared plus 4x. So instead I'm going to move everything to the right, put 0 on the left-hand side. Doesn't matter, 0 can be on the left or right. So if I subtract 8x here and subtract 6, then what do I get? 0 is equal to 2x squared minus 4x minus 6. So this equation, so now I can move the 0 over to the right if I want. So 2x squared minus 4x minus 6 is 0. So whether it's 0 equals that or that equals 0, it doesn't matter. I'm going to simplify this. I'm going to divide everything by 2 because I have to factor this. So the easier it is, the cleaner it is, the easier it'll be for me to factor. So if I do that, I get what? X squared minus 2x minus 3. 0 divided by 2 is still 0. And now if I factor this, what do I get? Well, I get x minus 3x plus 1. Now I can use 0 property rule. So x minus 3 is 0. X plus 1 is 0. So that means x equals 3 or x equals negative 1. But I have to check this. Remember, once I get an answer, I need to check. And specifically, what do I need to check? Well, I need to make sure that whatever answer I got here doesn't cause me to get a 0 in the denominator. So if I would have ended up with x equals negative 2, well, if I put negative 2 in this first term, that's fine. I can have a negative 2 in the denominator. But if I plug it in here, negative 2 plus 2 is 0. That would make this guy undefined, which means negative 2 is not an acceptable answer. So I can have 3. If I plug in 3, that's fine. I can have negative 1. That's fine. It doesn't make either denominator 0. So in this case, both answers are good. X is 3 and x equals negative 1. And again, you can plug them in. So if I plug in 3, 3 over 3 is 1. If I plug in 3, that gives me 5 here. 5 over 5 is 1. 1 plus 1 is 2. Okay, that's good. If I plug in negative 1, 3 over negative 1 is negative 3. Negative 1 plus 2 is 1. So 5 over 1 is 5. 5 minus 3 is 2. So that answer also works out. So you just have to be careful specifically that you don't get a 0 in the denominator by any answers that you get. All right, I'm going to erase this whole one. We'll do a radical example. All right, so for this example, let's say I have 2x equals 1 minus the square root of 2 minus x. So when we are solving radical problems, we want to isolate the radical and raise each side to the power equal to the root. Because that'll get rid of our radical symbol. So in this case, because I have square root, I'm going to get the square root piece by itself and then square both sides. So if I do that, let's go over here. What do I want to do? I want to subtract 1 from both sides. So I get what? 2x minus 1 on the left is equal to minus square root of 2 minus x. So now to get rid of that square root, I need to square both sides. So square the right, which means I also have to square the left. So on the left, I have 2x minus 1 squared. Well, that means what? That does not mean 4x squared plus 1. I don't just square this guy and square that guy. This thing is really 2x minus 1 times 2x minus 1. So please be careful with this step. This is where I see a lot of errors happen because people just say, oh, well 2x minus 1 squared is 4x squared and negative 1 squared is plus 1. So this whole thing is 4x squared plus 1. It's not. You're missing that middle term from your FOIL. So when we do FOIL here, we get what? We do get 4x squared. And then what? Outside is minus 2x. Inside is minus 2x. And then plus 1. So we get 4x squared minus 4x plus 1 for the left side. So you can see that this piece here was missing from up here if we just squared each piece. So be careful with that. On the right side, so this is like a negative 1 in front here. So negative 1 squared. So here I can just bring the squared in. Why? Because it's multiplication. Here it was addition or subtraction, so I couldn't just bring the squared in. Negative 1 squared is positive 1. And when I have square root and then I square something, what happens? They basically cancel each other out, which means all I end up with on the right side is this 2 minus x. But this step that we just did is the reason that we must check our answers at the end. And why is that? Well, I could have this, right? Let's see, I don't want to write this. So if I have, when I square it, I essentially would get rid of a negative symbol. So if I have whatever, 4 equals 4, and I square both sides, I get what? 16 equals 16. That's true. So I started with a true statement, I squared both sides, and I ended up with a true statement. But I might also have the following. 4 is not equal to negative 4. But if I square both sides, what happens? 16 is actually equal to 16. So the final result I get, these two might be equal because I squared it, but the original might not have been equal before I had started because of that minus sign. So because I squared both sides, I essentially took out that concern of the minus sign, which is why when we get an answer at the end, we have to go back and check it in our original to make sure that in fact, when we squared it, we didn't cause a problem mathematically. So now let's move everything over, solve this quadratic, so we get what? I'm going to subtract 2 and add x to both sides. So subtract 2, add x. So I get 4x squared minus 3x minus 1 equals 0. We can factor this guy. So I get 4x and x, and then minus 1 plus 1. So 4x times x is 4x squared, minus 4 plus 1 is minus 3, and then positive times negative is negative. So use our zero property rule, so 4x plus 1 is 0, x minus 1 is 0. Move this 1 over, so we get 4x equals negative 1. Divide everything by 4, says x might be negative 1/4. And how about here? Add 1 to both sides. So I said x might be equal to 1. So now again, I must check my answers. Plug in the negative 1/4 into the original. So let's do this in red so we can see this is checking our work. And when you're doing this, I prefer that you write out the work showing that you checked it. Don't just say, like if it's on an exam and I don't see that you actually checked your work, I don't know if you did or not. I'll probably take a point off, and don't come back the day later and say, oh, I just did it in my head. I don't want you guys doing math in your head. So write it out here so I know that you in fact did check your work, that you plugged it in. On the last problem, if you just want to put like a note like, okay, these answers are fine because they don't make the denominator 0. Then I know that, yeah, you kind of checked it in your head, but the concept was correct. This you can't really check in your head. If you plug this in your head, you're doing a bunch of calculations in your head, which could be trouble. So here if I plug in -1/4, I get 2 times -1/4, and I want to know, is this equal to 1 minus the square root of 2 minus 1/4? So this side I get what? 2 times -1/4 is minus 2/4, which is minus 1/2. Over here on the right, I get 1 minus square root 2 minus 1/4 is 2 plus 1/4. So that means what? It's 8/4 plus 1/4 is 9/4. So 9/4. Whoops, this should be minus. Square root of 9/4 with our radical rule is what? We can split the top and bottom. So this is like 1 minus the square root of 9 over square root of 4, which is 1 minus 3/2. So square root of 9 is 3, square root of 4 is 2. 1 minus 1/2 is -1/2. So yes, they're equal, so I know that this answer is good. Running out of space here, going to erase this. I'll do it over here, so if you still need it. Now we got to check +1. So 2 times +1, is that equal to 1 minus the square root of 2 minus 1? So 2 times 1 is 2. 2 minus 1 is 1, so square root of 1 is 1. So 1 minus 1, 2 is not equal to 0, which means x equals 1 is not a valid answer. So you can see that the work we did was fine, but it gave us an answer that was not correct. Did not work for us because of that squaring the answer. So our answer to this one is x equals -1/4. That's it. So those are the 2 other types of problems you'll see that you have to solve. Rational expression, radical problems. You must, as I said, check your answers at the end for those problems. That wraps up section 1.5. Come on back and we'll look at the next section.